Convert two images to numpy arrays and compare pixel by pixel. I'm using Pillow to load two images, apparently black and white, however in RGB format, and convert to grayscale. I can't use OpenCV. I convert them to numpy arrays. What I ultimately want to do is, 1. Count all the black pixels in each array and, 2. Compare array to array pixel by pixel and count the number of matching black pixels. What's currently confusing me is when I print one of the arrays print array.shape, I don't understand what I'm looking at. I'm using np.set_printOptions threshold equals nan to print the full array, but it appears to be a series of elements with way too many values than I would expect. I would think each element would contain either a single 255 or 0. Am I doing this the correct way in order to work with black and white pixels? When I attempted to convert to binary 1, I got true, false results which confused me a little more. Also, assuming array and array look identical, but are actually off by a few pixels, what is the best way to incorporate a fuzzy logic to the pixel by pixel comparison of the two? Just for additional information, image.size and image.mode return.
For starters, the L mode in the image.openVisualFileName.convertL does not convert an image to black and white, rather it converts the image to a grayscale using the following formula. L equals a 299 1,000ths plus G 587 1,000ths plus B 114 1,000ths.
Being R, G and B, red, green and blue respectively.
This formula goes throughout the image and change a 3, RGB, channel pixel to a 1, grayscale, channel pixel that best approximates the 3-channel color scheme. And that is why at the end you don't get only the values 0 and 255. Instead you get a pixel with values ranging from 0 to 255. To compare all the black pixels between two grayscale images, first you have to define what black really means. Is a value like 10 black enough, or 25 is already black for you? You got to remember that color is not absolute, and its meaning can change depending what you are doing. Therefore, a way around this is to set a threshold in which you will define what is black for you. Using a simple threshold function would do. So, I think this simple code might solve your problem. This code renders the following. Edit. Let's take a better look at the following line. TSH underscore array 1 equals 0 TSH underscore array 2 equals 0. TSH underscore array 1 equals 0 returns an array with the same shape as TSH underscore array 1 with value true in the position of a 0 value and false otherwise. TSH underscore array 2 equals 0 is the same as A where clausule. It filters the previous item where tsh_array2 equals 0. The result is an array that looks like that. Since true is the same as 1, the sum of this array will return the number of zeros in the same position in the two arrays. I hope it helped.
Sounds like you want numpy arrays to me. When I do that, I load the images to array by using cv2 with im equals cv2.imread file path, cv2.imread_unchanged. Using a demo img of mine, I get img.shape 2576, 4592, 3. img.max 255. img.min 0. Comparing it to a second img results in a boolean for each pixel which says if these pixels are identical. See. Second part of your question is a bit tougher. 1. Offset in XY direction. Then you probably could try to find that by embedding both images in larger arrays. Now you could work with clustering approaches to find key areas which you then try to connect. This should result in a shifting and maybe rotation, which should be the translation between the two images. 2. An offset in color, on the other hand, would require something like a subtraction of both images. Now you could use the sum and calculate ratios to extreme cases like black and white images. 3. Fuzzy logic. You could move away from the idea of comparing index to index, but sliding a window over each image and compare the sets that are shown in the windows. Edit 2. For not using CV2. You can skip the CV2 load and just use np.array like you did in your question. I just used CV2 because I had no pill installed and wanted to show you demo.
If you want to see more, please consider subscribing.